class, and she was like, "It's okay, this is fine." I think
Fansicle. Every time she does this to me. All right. Okay. All right. Let's walk through. I don't know if I clicked. Oh, I did. Good. All right. We're going to go through a couple notes here today. It's based on the trig functions. You need a calculator, so if you need to borrow one, I got one in the back, or I got a bunch of beer. You need it. I want to make sure that you guys know how to do it. We have a couple things I want to talk about today. I want to do just maybe 2 problems based on this stuff. I think you guys are pretty familiar with it. I just want to make sure that everyone's solid. You're getting the same answer as me, and then we have to talk about something new. And so that's the part that I'm a little worried about, and I want to get to that today. That's the new stuff today. All right, so let's jump right in. Remember, the trig functions, SOHCAHTOA, it's sine, cosine, tangent. We have those buttons on our calculator up there. If we find angles, you have to use the inverse buttons or the arc buttons. That's what they're called on your calculator to find angles. We'll do one of those today. So I'll do one where we find a wall, one where we find an angle. I want to do it for sine and for cosine or tangent today. We didn't do too many of those the other day, so we'll do one of each. And then my third example today is something brand new that we have not discussed, and so I want to make sure that we're aware of it. We have a Google question of the day that will go live here in about 10 minutes, and then I'll turn you loose on that and you'll have some time. We had homework due yesterday. We had a Google question of the day that's due, I think it was due today, but we have a new one today that's going live here in a little bit. And it's the same stuff. It's solved for a missing wall, or missing walls, plural. And that's one of my examples I'm going to talk about. Okay? All right. Are we good to go here?
Yep.
Okay. Let's start right in off the bat. Okay. So, where's my pencil at? There it is. Okay. All right. So first of all, let's do my first example here. Let's say my triangle is right here. So this is my right triangle. Okay, here's my right triangle. And let's say that we are given that this is x, this is a 15, and let's go yards. And this is a, this is an, say this is an 80-degree angle. Okay, that's 80 degrees. Okay, and I want to find x. So this will be my first example here out of many. All right, so now we need to label the picture. So let's talk about the labels here. What is the wall with the 15 called?
Adjacent.
The adjacent. How do you know that?
It's adjacent to the triangle.
Okay, it's right next to it, right? Okay, that's good. What is the wall with the x called?
Hypotenuse.
The hypotenuse. It's the biggest wall. That one's kind of the obvious one. It's the only wall that doesn't touch the 90-degree angle. And then obviously the only wall that I did not use in this particular case is the opposite. We're not using the opposite in this one. So by thinking about SOHCAHTOA, SOHCA and TOA, by using this little acronym, I'm using adjacent and hypotenuse, so I can narrow down that I'm using this formula right here. How I'm doing that? These are the 2 letters I'm using. I'm using adjacent and hypotenuse, A and H. That's one way you can do it. Or the other way to think about it, if you don't want to just look at the 2 letters you're using, what letter are you not using? Right? I'm not using opposite, so I can throw the ones with O's out. I throw sine and tangent out, the T and S one, just because we're not using it. So we're doing cosine on this problem. And again, what the cosine formula is, it is cosine of your angle, whatever theta is, that's your angle. It's adjacent over the hypotenuse. That's what A and H are. Okay, that's my formula. So my angle, what is it? 80. Cosine of 80. 80 degrees is the adjacent 15 yards over x, and we have to solve. Now, let's talk about through this, and then we'll type it in calculators. If you need a calculator, let me know. Anyone need a calculator, especially the 2 that walked in late? You guys need a calculator at all? Okay, clearly not. That was the funniest thing I've ever seen. All right, that's going to be good. All right, how do we solve for x? If you walk me through it. Who can walk me through how to solve this thing?
Just do 15 divided by the cosine of 80.
Yeah, yes, that's right. You'd have to multiply the x's. Sorry, you totally missed what Bree did. Oh my goodness. All right, you're gonna multiply the x across. And you're going to divide by the cosine of 80. Oh my god, I'm going to laugh about that for a while.
What'd you do?
I'm like, do you need a calculator? She goes, and just smacks her in the face, and then she fumbles it down. Oh, sorry, Bree. Moving on. All right, so like you guys said, we're gonna divide by the cosine of 80 here. Oh my god, I'm crying and laughing at that. So we have to type that in. So here's how we do it. We type in the 15. We divide by the cosine of 80. Close the parentheses. Let me just show you this on a calculator, my calculator screen, just so you guys can see what I'm typing in. All right, there it is. So 15 divided by cosine 80. That's how I can type mine in. I just use the division sign for the divide, and when I hit enter, it tells me a negative 135. So I don't think I'm in the right mode. I'm not. Hold on. I clearly reset my calculator. I'm like, that doesn't make any sense. There, 86. All right. Sorry. Hey, there's a perfect example why you have to make sure it's in degree mode, not radians. I must have switched to radians for calc. So, all right, it's 86.38. So that negative 135 made no sense for my numbers. All right, so question.
Can I look at my jacket?
Yes. Okay, so we have an 86.38. That number should make sense. Now, I want to talk about the common sense way to like check your answers here. So what we're getting here for my final answer, we're getting the 86.38. All right, now that's in yards. Now here's how I think of this problem before I move on to the next one. Is like a common sense check. The biggest wall should be across from the biggest angle. That's a property we talked about in geometry class. So the biggest wall is obviously the hypotenuse. It should be across from the biggest angle. It is. So I knew that my wall had to be larger than 15. Okay? Clearly 86 is larger than 15. I know that. The smallest wall will be across from the smallest angle. So the smallest angle of my triangle is this one up here. This angle is 10 degrees. How I know that? The remaining two angles of your right triangle, have to be complementary. So these two angles that are left over, these two right here, have to add up to be 90. That's what complementary means. And the big thing is, like, this is the smallest angle. That has to be the smallest wall. 10 degrees is a long ways away from 90 degrees. Like, it's quite a ways off. And that was already a 15. So when you scale up an angle, the wall scales up a lot faster. And it ended up being 86. It's not a perfect proportion. You can't set it up as a proportion, but it gives you a sense for, like, the number needs to be a lot larger than the one that's across from 10. Does that make sense how I'm justifying my number?
Yep.
I'm using a rough approximation of what it should be. The wall across from 10 is 15. The wall across from 90 should be a lot bigger than 15 because that angle is a lot larger. That's why the 86 makes sense to me. Ooh. All right, let's move on to the next one. So this is the second example now. Same exact concept, but now we're going to talk about in terms of maybe just a rough example here. So let's say that we have a building. So here's my little skyscraper here. Okay, and we're going to be, I don't know why it won't let me draw that window there. That window's open, I guess. All right, and the idea is that we're going to be putting a ladder up against the side of this building. Okay, so I don't know where it's going to reach. Let's say this is my ladder, and let's say it's a 100-foot ladder. It's a 100-foot ladder, and the ladder itself is at, let's say the ladder itself is at like a 65-degree angle. Okay, you lean it up. You can test that. Now, how you can test angles, your cell phone can tell you angles that you tilt at. Every cell phone, Android, smartphone, Apple cell phone, they have a built-in level. So when you go into the measurement app on an iPhone and you turn it on, it tells you 0. Like if you tap it on the ground, it'll say 0. And when you lean it, it actually tells you the angle that you're tilting at. So a lot of people don't know that. Let me just bring this up so you guys can see this. So I'll bring up the measurement app.
What's that circle in the back of your phone?
It's the magnets for the MagSafe charger. So it's just on the case. They're built into the phone, but the case gives you double the magnets. So All right, so you're in the measurement app for an iPhone. If you click the little like level tool, it gives you an angle that you tilt at. And when you tap the screen, it levels back out at 0. So you can put it on anything. So if you put it on the ground and hit 0, it zeroes it out, and then when you lean it, it tells you the angle that your ladder is at. And you can just lean it right up against the ladder. So it's actually really accurate. They're a little more accurate than the actual like level things that you use in like construction. It's kind of handy. It's a handy little tool. So, what?
Are you sure they're more accurate than?
Yeah, just because the little like bead, that little like water bead, air bubble, is not accurate. The reason why is that the bubble's too big for the marker that you're looking at. So I've actually seen those things like when it says it's level and it's not. Just because the bead, that water bubble, actually gets stuck in the tube. And it doesn't actually flow because there's actually friction in the tube itself. This actually gets down to like the nearest degree. That bubble can't. It can get close. And the weird thing is the phone actually uses that still. It uses the gyroscope. So on the inside it actually uses that, which is weird. So.
Is that what it uses like when you turn your phone in?
Yeah, it uses the gyroscope and it uses the level to know like which way it's tilted. Same with your Apple Watch. The Apple Watch is off. When you lean it up, it turns on. It uses the same level system. So, all right. Okay, so first of all, we have this. My question on yours is, what is the height of the building? And how far is the ladder away from the building? These are my two numbers. I need to find both. So that's what that was kind of like the problem we had yesterday for the story problem for your trig functions. All right, so we can solve for any letter first, whatever one you want to do. But let's talk through it. Let's go through this here. So what do we have? How do we do it? How will we solve for x or y?
Sine 65.
Okay. Okay. So if we do the sine of 65, keep going. Is x over 100. Okay. Now let's talk about that. Why we can set up sine. Sine talks about opposite and hypotenuse. On this picture, this is the opposite wall of the 65, and this is clear that the hypotenuse is the biggest wall of that right triangle. And that is a right triangle. Hopefully that building is straight up and down. The opposite is x, so I set it up. To solve that one, you'd multiply the 100 across, get rid of it off the bottom. So I multiply that 100 across, and so I'm going to take the 100 times the sine of 65, and hopefully you're in degree mode. Make sure, like you saw my calculator earlier, it has to be in degree mode for this thing to work. Otherwise it tells you weird stupid numbers like negative 100 something that made no sense. So on my calculator screen, if we go back to my calculator, I'm going to type in the 100 times the sine of 65, close the parenthesis, 90. So the building's about 90 feet tall. So it's a 9-story building, roughly. Could be 8 stories, but so this turns out to be 90.6 feet tall. That's my x. Okay, questions with how we set that up? Okay, now that I know that this is 90.6 feet, now what we can do is we can use any formula we want. Anyone other than sine. We've already used sine. We can use any formula we want. Actually, we could still use sine in this case to find y. Let's use cosine, or you could use tangent. We can use any one you want. And I said you could use sine, but you have to use the other angle across from 65. That other angle up in the top, which is 25, something like that. Yeah, you could use the other angle up in the air. But yeah, let's do cosine. I think cosine is the easiest. So if we do cosine of 65. If you don't remember what cosine stands for, it stands for adjacent and hypotenuse. So cosine of 65 is the adjacent over the hypotenuse. This is the adjacent side. Then you multiply my number across. So again, if I go back to my calculator screen, I'm predicting that this number will be smaller. Let's see, where are we at? So 100 times the cosine of 65, because that's using the adjacent wall, 42 feet from the building. So this ends up being y equals 42.26 feet from the building. There's other ways to do this, and that's what we're going to talk about on Monday. Other ways to do that same problem. questions at all about the types of problems we did today?
How does that make sense?
What are you talking about?
The ladder's only 100 or 9.4 feet taller than the building.
Yeah.
It has to lean 46 or 42 feet.
No, the ladder is 42 feet away from the building, and the building itself is 90 feet tall. That way, the hypotenuse works out the way that it does. So, that's what your question there is. What we're going to talk about Monday. So bring that back up. So, I know what you're thinking. It doesn't. The numbers don't seem like they're right. It just seems like it's too far for how tall the building is. Yeah. So we're going to talk about that. So. That's the question for Monday. So, all right. Questions at all about that? That was good though. We're going to come back to that. All right. Okay. New thing today. And that's what your homework's based on. The new thing today is something that you may have remembered from Algebra 2. I don't know if you've seen this stuff in Algebra 2. We have to talk about the reciprocal functions. All right. Okay. Shh. All right, let's stop talking here. We're almost done. This is my last slide today. Ignore the 4 out of 8. The 8 slides were from yesterday. I didn't delete those yet. Okay, the reciprocal functions. These are the other functions for the trig functions. Your calculators do not have these programmed in. I think I've only had one calculator in all my years that actually had this programmed in. It was a Voyage 200. It's like the biggest Texas Instrument calculator they make. I needed it for Calc 3 at the time. I could do multiple variables. And after that class was over, I got rid of it because it was super expensive. The reciprocal function, how this thing works is every trig function, cosine, sine, and tangent have a different trig function that's also paired with it. And the pairings go like this. For cosine, it is matched up with secant. Secant is a different trig function that it's paired with. I'll talk about that here in a second. Sine is paired with cosecant. And tangent is paired with cotangent. Now, I know the question that somebody's going to ask is why are the S's paired together and the C's paired together? Yeah, I understand. I agree. There's a reason why certain ones are the way they are, but here's how I remember this. When you're talking about reciprocals or just trig functions in general, every trig function, no matter which one of the 6 you pick up here, is always paired with, it's always in a pair where one of them starts with the letter C. Every pairing has one of the trig functions that starts with the letter C. Every pair. Only one of them starts with C. So on secant, the other one was cosine. On sine, the other one was cosecant, right? There's always one of those pairs that has a C. Tangent has cotangent. Does that make sense now? Every pair has one that starts with the letter C. Now, what these are, I said they're the reciprocals. If you don't know that definition, it means you take the fraction and you flip it over. So for secant, I'm going to use this in blue, it is the reciprocal of cosine. So what was the fraction for cosine that we did earlier? Yeah, it's adjacent in the hypotenuse, so that's cosine. So for secant, did you say the wrong one? Oh, I thought you said the wrong one. All right, for secant, yeah, that wasn't convincing. All right, for secant, it's SEC. They don't have this on your calculator, sorry. I don't think any calculator I know of other than that Voyage 200 has these. For secant, you actually flip it over. It's hypotenuse over adjacent. That's why it's called a reciprocal. You're just flipping the fraction over. Now, why you'd ever want to do this? Obviously, Google and any like high-powered calculator can do this. You can always change the fraction so the variable can be on the top. That's why it's important. You never have to have the variable on the bottom and never have to divide. You can always multiply. So you can, like maybe the hypotenuse is the x, like the last problem I did. You can move it up, and so the hypotenuse can be on the top of the fraction. So I can just multiply the number across. So for secant, or for sine, cosecant is written like this. Cosecant is written as CSC with an angle behind it, and And the idea is that the fraction would flip over and be hypotenuse over opposite. That's the opposite of sine. And then for tangent, it would be cotangent of an angle is the adjacent over opposite. Right? You can flip them over. That's the only thing. I just want you to get these written down. We'll talk about them on Monday, but we have some other weird stuff to talk about Monday, especially the thing that Ray brought up here. So. Okay, you have a Google question of the day. It went live 2 minutes ago. It's a trig function. You have to solve for x and or for b and c on the picture. It's for b and c. It's a story problem. I think it's got a tree and it's got some walls that are missing.
Mr. Ward got a lint roller.
No, do you want some tape?
Yeah, I was scared I forgot it. But I feel like you would just
I don't think I have duct tape.
like, so how long would you like to
I don't have duct tape, but I might have like
I hope I didn't like forget to do 2 whole pages or something like that. Or kind of like busy tasks with boxes.
sorry, bud. I don't have tape. Somebody borrowed it.
I have this stupid black stuff.
Here, just do this. Just wrap this around your hand a couple times.
It's not gonna work. It always works. It's gonna take forever.
Or just do this. Just pat yourself. Pat it. There you go.